Hi, this presentation is called Perma Pure MD and MRD Dryers, Introduction and Performance. In this presentation, we're going to cover all of the Perma Pure MD gas sample dryers with Nafion product range. Hi, this presentation is entitled Perma Pure MD and MRD Introduction and Performance. And in it, we're going to cover the entire line of Perma Pure MD gas sample dryers with Nafion. Before we go right into those products, let's talk a little bit about what Nafion is and what makes it so unique. So Nafion is a copolymer of Teflon and sulfonic acid and is highly resistant to chemical attack. Nafion removes water by a first-order kinetic reaction, so equilibrium is reached very quickly, typically within milliseconds. The transfer of moisture is driven by the differential vapor pressure between the membrane sides. And Nafion permeation selectivity is based on chemical reactivity, not the size of the molecule. So it's not traditional permeation. And then there you could see on that diagram to your right, we're showing the sample gas flowing, in this case from right to left. You can see the red, green, and yellow jelly beans represent the analytes or the components in the gas sample that you're looking to measure. And the blue jelly beans in the center are the water that is then escaping from the sample gas. And it's not traditional permeation. So traditional permeation is analogous to something like a bug screen, where you have holes in the screen that are sized to the type of molecules or components you want to move through the membrane. That's not what Nafion is. With Nafion, the water actually becomes part of the material's chemical structure, and because of this, it is highly selective. So only compounds that chemically associate with sulfonic acid permeate through Nafion. Because this is a specific chemical reaction with water, the process is very selective, and most gases being dried are entirely unaffected. And that is exactly what makes Nafion so valuable to the scientific community at large. Now let's go right into the MD series or monotube dryer series. These dryers are designed as a simple tube and shell design that functions with water vapor, similar to how a heat exchanger transfers heat. So on that diagram below, you can kind of see the way the MD series dryers work. The sample gas inlet is at the left, and the sample gas, what you're trying to dry, goes from left to the right. It enters wet and exits dry. And we have a counterflow purge gas that enters at the right and exits at the left. So what you have is a transfer of the moisture through the membrane, and you have the sweep gas or purge gas actually physically remove the moisture away from the outside of the membrane tubing. Now, Nafion is a very predictable material. That is, the performance can easily be measured. If we have a strict set of conditions on the sample gas, that is, we know the flow, we know the temperature, we know the moisture content, and if we know those same variables for the purge gas, the flow, temperature, and moisture content, we can predict the performance of the dryer. And indeed, this is what we've done with our performance curves. So the MD series dryer can be had from us in a number of different ways. In the center there, you see some of the shorter dryers in straight configuration. Those are the 12-inch or 24-inch versions are shipped from us in a straight configuration. Towards the left and the bottom right are various coiled configurations. We have some standard coil configurations. Usually we coil them in about a 7-inch diameter, about 20 centimeters in diameter. That's our standard coiling configuration. but those others that you see in the diagram are custom coiling configurations that we've done for some of our OEM customers. At the top right, you see our MDH series. That is our heated dryer, which is indeed just a standard MD dryer coiled with the first portion of the dryer heated. And on the bottom left, that is our MRD series. That is our rotating dryer with rotating ends. So let's look at the general features of this dryer. They have flow rates up to 4 liters per minute, depending on the tubing ID. Operating temperatures to maximum 120 degrees. So the maximum operating temperature is dependent on the material. With polypropylene, that temperature is 80 degrees C, fluorocarbon 90 degrees C, and stainless steel 120 degrees C. You would not only pick those materials based on the temperature, but also based on the corrosion resistance required of the sample gas that you're actually trying to dry. We have operating pressures to 100 psi, straight or coiled configuration. They're corrosion resistant due to the materials being used. And we get standard dew points to minus 25 degrees C, with minus 60 degrees possible in special cases. There you'd contact us for some additional advice there. There are no moving parts, and the dryer continuously regenerates. That is, the performance does not decline over time or does not get used up. Here is our intelligent product numbering system for the product. I just want to go through this shortly to show you the different variations. On the top, you can see the MD stands for the product series. The next number is the tubing size. In this case, it's 110 or 110 thousandths. That's the OD of the Nafion tubing. We also offer that in 0.070 and 050 sizes. The next number is the length in inches, and that's not the total length of the dryer. That's actually the active length in the Nafion that we're promoting there. So you can see the different lengths. 12 through 288 inches are standard lengths. The next digit shows the shell and connector material. We usually combine those as being the same. That means if you have a polypropylene dryer, you'll have a polypropylene shell and polypropylene end fittings. Same goes with fluorocarbon or stainless steel. But there are actually instances where you want to combine different ones. So we also offer FEP or the fluorocarbon shell with polypropylene connectors, and also the FEP shell with stainless steel connectors. This is where you want to have the temperature capabilities of the stainless steel, and you still want to have the flexibility of the FEP shell. So there you see the letters there that you pick for each of those. We also have the E there. That's for element only. That's for the spare part if you just want to replace the Nafion element inside the dryer. So the last digit is the sample gas connector type, and that spells out the size of the connection. So number 1 is 1/16 inch compression fittings. That's only available on the MD050. And the other sizes, the 1/8 inch and 1/4 inch compression fittings, are for the other sizes. So moving right along to the MRD series, this is what we call our rotating dryer. This design is a little bit different than our standard. We have special rotating ends that allow easy adjustment of the purge gas fitting placement without twisting the inner tube. This is particularly important for tight spaces in your cabinet or housing where you need to move that purge gas fitting into the right direction. This has standard materials of FEP tubing with Kynar end fittings. It also has an improved O-ring sealing system separating the sample and purge gas. So we have a number of customers that are using this on PPB level analyzers, and they found that those seals do a better job in that application. We have a wider range of end connections available, including metric 6mm, and this one is available with 0.70 and 110 tubing sizes only. And here the part number system is a little bit different than the standard MD. You see the series and the tubing sizes are the same, as well as the length. But here we break out the shell, fitting, and ferrule materials separately in case you want to make a combination of those. And also importantly are the 4 digits at the end that allows you to choose the connections individually for each sample and each purge gas connection. And we find this as helpful sometimes in some custom applications where people want to match precisely their sample fitting to the tubing that they're using in their system or equipment. Just want to show you our performance curves and how to use them. These are our standard performance drying curves. They're all generated by using saturated ambient air, that's 20 degrees C dew point at 20 degrees ambient temperature, and using dry instrument air as your purge gas in 2 times of the flow. That instrument air purge gas is also at ambient temperature with a dew point of minus 40 degrees C. And let's just take a look at that center graph there. Let's say we want to get to a dew point of 0. We can see right in the middle there at a dew point of 0, we have a flow rate of 2 liters per minute. That gives you right in the middle. If you have a flow rate of 2 at 0, you're going to be choosing the 48-inch length dryer there. And that is a baseline way of choosing your dryer for your application. Now, there are other variables that could help you choose a dryer that is more specific to your application, and those are covered in another presentation called Best Practices, how to choose the right dryer for your application. That goes into that detail a little bit more. Here we're just going to go over the basic performance on how to read the curves. The next series of curves show the pressure drop. So if we take a look at that very same application of 2 liters per minute, you can see there on these curves the pressure drop of the MD070 in the center there is roughly 0.26 or 0.27. Those are in inches of water. That's what that's shown as. You could see with that same application your pressure drop on the MD110 is a lot less. That's that graph on the right. That's because the tubing diameter is larger with that dryer. So let's go to the MDH. The MDH dryer was a special heated dryer that we developed. That's a coil dryer with only the first portion heated. We have some customer experience that has really tightened its application a little bit. I wanted to share that with you. The first 12 inches are heated to 80 degrees C, and it's for sample streams with higher than ambient dew points, so up to 70 degree dew point, and 30% water by volume at 1 liter per minute is roughly your top end performance of this product. You have a faster moisture transfer at inlet, primarily due to the higher operating temperature. And in fact, one of our customers pointed out that they got better results with this dryer precisely because that inlet was heated and they were able to transfer the bulk of the moisture from their sample stream at the inlet faster. They weren't really looking for the lowest dew point. They were looking for fast transfer rate. We recommend up to 10 times of the purge flow. The reason why we recommend this is that the higher temperature or higher operating temperature of the dryer doesn't give you such a low dew point. The low dew point is somewhat dependent on the operating temperature. And this is available in 110 and 220 volt DC versions. So let's look in general of our MD customer experience. We've been making these dryers now for over 40 years, and in general they've been successful because they are rugged, corrosion resistant, continuous and self-regenerating, reliable and long-lasting. They have predictable performance, they're cost-effective, and they're maintenance-free. Just to go over some typical drying applications: naturally sample gas conditioning to remove water, for the protection of equipment, for higher accuracy, to retain water-soluble compounds, and continuous stream or batch water removal. They're also used in sample gas conditioning for SEMS, primarily for low flow applications, as MDs top out around 4 liters per minute. They're also used for continuous drying of ambient air for use in other processes, and also for aerosol and particulate analysis with flow rates less than 1 liter per minute. And to round out our presentation, when you come to us for application help, we ask you to fill out our Perma Pure 10 questions that are shown here in this graph. You can ask any of the Perma Pure customer service or sales directors for these questions, but in general, when you contact us, we ask that you include as much information of your application as possible, as shown here in the graph.